Morning, good afternoon, good evening, depending on when you're watching this. It's your boy Mr. Malachi, and I'm back with this other video where we're gonna be discussing and really going through how do we draw straight line graphs. So I'll show you two methods, right? They both have its pros and cons, so you ultimately need to decide which one you prefer. I personally prefer the second one. The second one has less work that needs to go into it, but like I said, I'll show you both methods, and yes, at some point you need to decide which one you prefer. So let's take an equation. So there's a simple linear. Actually, let me take something that has a -3. So there is a linear graph. It's in standard form. Y equals to something times x plus or minus a c value. So it's definitely in standard form. So the first method is called the table method. And as this method suggests, we need to be drawing a table to actually calculate for these methods. So there is our table. At the top we have x values, at the bottom we have y values, and what we're going to choose is a range from -3 going all the way to +3. So these are the x values that you always choose. So these you always choose that range, right? And then we need to then find what these y values are, these corresponding y values. And the way we do that is we use our equation, we substitute these values for the x, and then we solve for the corresponding y value. So let's do the first one. So if I wanted to calculate the first y value, let me use a different color. It will be y is equal to 2. The x value was -3 minus 3, and so what is this y value? That is a -6 minus 3 is a -9. So this corresponding y value is a -9. So let's keep doing that for the next one. 2 -2 minus 3, that you get a -4, and so that is a -7. Let's substitute the next one. 2 -1 minus 3 is a -2, that is a -5. And you would keep doing this for all those other x values, and for this one you'd be getting a -3. At some point you should see the logic that is happening there. They're actually adding 2 and 2 and 2, but let's not just go with word of mouth. Let's keep calculating those values. So if it's 1 minus 3, that is a -1. This next one is a 4, it's a +1. And the last one is 6, it's a +3. So these are the y values that we get. So what does this actually mean? It means when we go plot this guy, this first column there represents a singular coordinate. So if you were to write all those coordinates out, the first one will be a -3 and a -9, a -2 that corresponds with a -7, and -1 that corresponds with a -5, a 0 and a -3, a 1 and a -1, a 2 and a +1, and lastly a 3 with a +3. So these coordinates are the ones that we're going to draw on our Cartesian plane. So let's do that next. Alrighty, so there's our Cartesian plane. Let's plot these guys. So -3, this is the line for -1, this is for -2, so this is -3 for the x, and that corresponds with the -9 for the y. So we'll have a point right there. You literally need to put it where the lines meet. The next one is a -2 and then -7. So that would correspond with that guy. Then the next one is a -1 and a -5. -1 for the x, -5 for the y would go there. Then the next one is a 0 for the x and a -3. So that will be on my y-axis. The next one is a +1, 1 for the x and a -1 for the y. And the next one is a 2 with a +1, so that will go there. And the last one is a +3 with a +3. And there we go. And when you join these lines, you make a perfectly straight line like that. All you need to do is put arrows there and also label it, the equation that was given. And there we go. So this is how you plot a graph using the table method. Let's then move on and look at the other method that you can use to actually plot these graphs. Alrighty, so for this next method, this method is called the dual intercept method. Some people just like calling it the intercept method. I just put the word dual there because it means two. So we're going to have to find the two intercepts. And once we have found the two intercepts, that's how we plot it. So with this one, we only need two coordinates. So how do you find the two intercepts? Let's first find the x-intercept. So again, there's our graph that's given there. But for our x-intercept, we need to remember that on the x-axis, y is always equal to 0. So we take that equation that's given, and we're going to replace y for, or we're going to replace the y with a 0. So we're going to substitute 0 there. And we still have our -3x plus 6. You take the 3x over, it becomes a positive, and you divide by 3, you divide by 3, and so our x-intercept is actually a 2. But how do you represent that as a coordinate? Therefore, the coordinate of that guy would be a 2 for x and a 0 for y. I hope you're seeing what's happening there. Again, if you're calculating the y-intercept, you have to make the y equal to 0. So that's the x-intercept. And by virtue, if you're calculating the y-intercept, then it should make sense to us that now we're going to make x equal to 0. Again, why? Because on the y-axis, the x-coordinate is always 0. So what we're going to do, we're going to take the equation again, the one that's given, and we're going to replace the x this time with a 0. So I'm going to keep the y, -3, and replacing the x with 0. And there we go. Then this, if you just plug it into your calculator, the 0 with the 3 times gives you a 0. So actually the y-intercept is actually 6. And if you were to represent this as a coordinate, it's a 0 with a +6. Right? So now we have this guy and we have this guy. Now we need to move on and plot it onto our Cartesian plane. Let's have a look at how we're going to do that. Alrighty, so we've calculated these guys. We need to plot them. So the 0, the 2 and the 0, that will go on my x-axis, so it goes right there. The 0 and the +6 goes right there on my y-axis. And then again, you need to join these guys with the perfect line. There's my line. It does not look as perfect as I would have hoped, but sure, that's how you would draw this. And again, you need to label this with the equation, and so y is equal to, what was it, a -3x plus 6. And there we go. quite easy. The two methods, you could choose whichever one you prefer. If the test and exams don't actually stipulate which method you should use, then you could ultimately choose. Obviously, the second one does look like less work, but yeah, some people prefer the first method as well. So before we end off the session, I want to give you one more example. And this example, I want to give you a equation, right? A formula that does not really look standard form yet. And I want us to still plot that guy. So let's have a look at how that would look. Alrighty, so we're given this equation here. And what we need to do is we need to first make it into standard form. We need it to look like this. Y is equal to mx plus c. So we need the first guy as soon as you're done with the brackets, or rather, we need the first guy immediately after the equal to sign to be the term that has the x there. And we need the last guy to be the constant. So how do we work with this guy? First of all, I'm going to take this and I'm going to take it over the equal to sign. But again, I'm cognizant that it has to appear immediately after the equal to sign. And I do not forget my golden rule about equation is that something goes over, the sign changes of that thing. So it was positive, now it's a negative. And how you get y to be by itself, you divide by 2, you divide by 2, and you divide that by 2. And so y is actually negative 4 divided by 2 is a negative 2x, or 8 divided by 2 is a positive 4. And if we were asked to solve, or rather plot this, we would therefore find our x-intercept by making y equal to 0. So I would take that equation and I would substitute 0 for y. This is plus 4. I'll take my plus 4, or rather let me take my x over. It's going to be a 2x is equal to a positive 4. Divide by 2 on both sides, and so x is equal to a positive 2. So there's my x coordinate, or rather my x-intercept. So that's how it looks. And if you wanted the y-intercept, I'd make the x equal to 0. And how does that look like? Y is equal to negative 2x plus 4. And so y is equal to negative 2, open bracket 0 plus 4. So y is equal to positive 4. And again, this is something that you can read off your equation. If you remember what this guy is, it's always your y-intercept, but that's how you would calculate it. So what does this tell me? It tells me x is 0 and the y is positive 4. Then how do we plot that? We need to plot this and we need to plot that. So let's move on to our Cartesian plane. Alright, there's our Cartesian plane. The 2 and the 0 would be right there on my x-axis. The 0 and the positive 4 would be right there on my y-axis. And then you would join this with a nice perfect line. And there we go. This looks a little bit more better than the previous one. It's just not as thick as I wanted. But yeah, you would label this guy the original equation, which was a 4x plus a 2y is equal to an 8. And there we go. So it's very necessary, it's very important to know how to make things the standard form, because sometimes they don't always look like that, and you always need to sometimes change it, have it to look like standard form, so you can actually, even if you're doing the table method, you would have to actually get it to look like standard form. So maybe let me do 2 more examples on how do we get these equations to look like standard form, and then we'll end off this video. So let's take some couple of equations and let's look at how we would change these to be standard form. So what if we have a 3y minus an 8 equal to a 2x? So standard form, remember, it's y is equal to mx plus c. So we need it to look like that. So the x is already on the other side. I'll just take my 8 over. That would give me a 2x plus 8, and I would therefore divide by 3 there, divide this by 3, divide this by 3. You need to divide them individually. So this one gives you a gradient of 2 over 3, and this one gives you a y-intercept of 8 over 3. So as a part of, as a added caveat to this, you could be asked what is the gradient. So you'd have to say gradient is 2 over 3, and the c is 8 over 3. So sometimes they would give you something like this, and they would ask what is the gradient and what is this y-intercept. So that is question number 1. Let's do question number 2. So question number 2, what if we had a negative 3x plus 4y is equal to 14? Again, we do the same thing. We're going to bring the x over this time. So it's a 4y is equal to a positive 3x plus your 14. I always write the x part first, and then I divide by 4, I divide by 4, I divide by 4, and so y is equal to 3 over 4x plus a 14 over 4 can be simplified into a 7 over 2. And so what is my m? My m in this case would be a 3 over 4. What is my c? My c in this case would be a 7 over 2. And there we go. Very easy, and I hope you get it, and I hope you actually benefited from this video. On that note, I will see you on the other side. Bye.